Okay, hello everyone. So today what we're going to do is kind of continue on what we were talking about during our last class with more of Pascal's triangle and how it relates to the binomial theorem. Okay, so we can actually find terms in our binomial expansion without expanding everything. Okay, so if you remember, the binomial theorem is a plus b to the power of n. This is kind of like a kind of shortened way of writing it, but it's a sum of n choose r times a to the power of n minus r times b to the power of r. So this is how it would be on your formula sheet. Okay, remember what that equals was n choose 0, because we start at 0 and go up to n. Then we have a to the power of n, b to the power of 0, plus n choose 1. Oops. And then we would have a to the power of 1, or sorry, a to the power of n minus 1, of n minus 1, b to the power of 1. Okay, plus n to the power of 2, a to the power of n minus 2, b squared, plus all the way up to n choose n, a to the power of 0, b to the power of n. Okay, so just a couple things to note here. For our first term, r equals 0. Then for the second term, r equals 1. And then our third term, r equals 2. Okay, so like we kind of talked about yesterday, therefore, r is 1 less than the term number. And also r only goes up to n, it never goes beyond n. And r will never be greater than n. Okay, so in other words, r is going to be less than or equal to n always. Okay, so say if we wanted the fourth term, r would be equal to 3. And if we want the sixth term, r would be equal to 5. Okay, so it's 1 less than whatever term number we're trying to find. Okay. Remember, when we expanded out a plus b squared, it had 3 terms. A plus b cubed had 4 terms. So by logical extension, a plus b to the power of 19 would have 20 terms. Okay. And then by expanding also, a plus b to the power of 10 would have 11 terms. If we're looking at the middle term, it would be term number 6, and it would be r equals 5. Okay, so say if we had 11 numbers. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What's the median of this data set? We look for the middle number, right? We would go 1, 2, 3, 4, 5, 6. Come from this side, 1, 2, 3, 4, 5, 6. They're both here. So 6 is our middle term. Okay. The way you can always find the middle term would be if you have a non-number terms, just divide by 2. So we'd have 11 divided by 2 equals 5.5 and round up to 6. Okay, so we know the sixth one is our middle term. Okay. If you had an even number of terms, say if we had 10 terms, then there'd be 2 in the middle. So I wouldn't ask you to find the middle term in that case. Okay, so we should divide by 2 and round up. So the sixth term would be the middle term. So if we're trying to say what the general term is, so without having to expand out 20 different terms, we can find the general term by t to the with a little subscript r plus 1. So that's going to be a term number is equal to n choose r to the power of a to the n minus r, b to the power of r. Okay, so it's very similar to our expanded formula, but instead of doing all the terms, we're just looking for one term. Okay, whatever term number we have here. Okay, so when we find the general term, it's going to be kind of half simplified, half not, because we won't know what the r is yet. Okay, but then we can use our general term in the following questions. So in the expansion of x cubed minus 5 to the power of 12, we want to find the general term fully simplified. Okay, so here we have our n. Remember, that's always the exponent. Is equal to 12. My x term is equal to x, or sorry, that'll be my a term. A is equal to x cubed, and b is equal to negative 5. Okay, so my general term formula will be t to the r plus 1 equals n choose r, a to the power of n minus r, b to the power of r. And now I just sub in everything. Okay, so I know that my n is going to be 12. Choose r times I'll have x cubed to the power of 12 minus r times my b is negative 5 to the power of r. So I don't know what r is, but I can simplify this a little bit. Okay, so I still have 12, choose r, and then I can simplify this bit, right? I'll have, actually, I don't think I need brackets anymore. Remember, when we have exponents to the power of exponents, that all just becomes multiplication up there. So I'll have 36. I have 3 times 12, which is 36 minus 3 times r, which is negative 3r. Okay, and then I still have my negative 5 to the power of r. Now, one last thing I'm going to do is I'm just going to switch these two because I want to put all my constants at the beginning. Just make it easier to multiply them. And I'll put my exponents at the, or my variables at the end. So remember, the r stays outside of the brackets because it's negative 5, so it'll go positive to negative, based on whether r is even or odd. 36 minus 3r. And that is my general term. Okay, so the one common mistake I see a lot with these kind of questions is people forget to multiply the 3 by the r here. You'll have 3 times 12, but not 3 times r. Okay, just don't forget to do that. So this is my general term. I have t r plus 1 equals 12 choose r, negative 5 to the power of r, x to the power of 36 minus 3r. Okay. So one thing I just want to draw your attention to is this bit right here, this exponent. Yes, I'm still in the call. So remember, r must be a whole number for combinations, and it has to be between 0 and 12. Okay, since n is equal to 12, we can't have anything bigger than 12. Okay. So what that means is that for B here, we want to find the term containing x to the power of 7 if it exists. Okay. So this means that we have to check R is between 0 and 12 and is a whole number. Okay. And how do we do that? Well, whatever our x term is, we have 36 to the power of, or 36 minus 3r. So this has to equal 7. Okay, my general term, the x is 36 minus 3r. So I set that equal to whatever exponent I'm looking for here. Okay, so I'm going to check if 36 minus 3r is a whole number between 1 and 7. Or sorry, 1 and 12, when it equals to 7. Okay, now I just rearrange. I'll bring the 36 over. So I have negative 3r is equal to 7 minus 36. Negative 3r equals, that would be negative 29. Divide both sides by negative 3 to cancel that out. So r is equal to, negatives will cancel, and we'd be left with 29 divided by 3. Is my r. This, when you divide it, is not a whole number. So r must be a whole number. Therefore, there is no term containing x to the power of 7. Or you can just say it does not exist. Okay, so you solve CR, and then you can just say it doesn't exist, and that's your final answer. Okay, for any constant term just means x to the power of 0, because x to the power of 0 equals 1. So then whatever number we find is going to be constant. Okay, so then we'll set 0 equal to, so for my check, I have 36 minus 3r, and that is equal to 0. Now this 36 minus 3r won't be the same for every question. It'll be whatever the exponent is in our general term. Okay. So now we can bring the 36 over again. We'll have negative 3r is equal to negative 36. R is equal to negative 36 divided by negative 3. So we have r is equal to positive 12. Okay, so this is a whole number. So we know that our check is good. Now we know what r is. Okay, so if I go back to my general term, I have t to the r plus 1 was equal to 12. Choose r, power negative 5, negative 5 to the power of r, x to the 36 minus 3r. Okay, now I can sub in r equals 12. So t is 12 plus 1 equals 12, choose r, or sorry, 12, choose 12 to the power of negative 5, or negative 5 to the power of 12, and then I have x to the power of 36 minus 3 times 12. Okay, so we can see that it's going to be the 13th term because t is 13, or t with the 13. So my 13th term, that'll do 12, choose 12, which should be equal to 1, times negative 5 to the power of 12 is 2, 4, 4, 1, 4, 0, 6, 2, 5. And then we'd have x 36, or 36. Negative 3 to the power 12 is also 36. So we have x to the power 0, which is going to equal 1. And that's why it's a constant term. So I have 1 times this big number times 1, which will just be that big number. I'll throw comments here to show that we're in groups of 3. Okay. So that is my final answer. The 13th term is 244,140,625. Okay. We can also find the middle term. Okay. So the middle term. And because it doesn't say it, if it exists, we know that there is a middle term. Okay. You don't have to do the check. So r equals 12. Therefore, 13 terms. So my middle term, what I can do is 13 divided by 2. That equals 6.5. Round up to 7th. So I'm looking for the 7th term. Okay. So if I'm looking for the 7th term, actually, I'm going to get rid of that. There we go. So I'm looking for a 7th term. So therefore, r equals 6, because my r is always 1 less than the term number. So t to the power of 6 plus 1 is equal to, I have 12, choose 6. Negative 5 to the power of 6. X to the power of 36 minus 3 times 6. Okay. So then that will be my 7th term. And you guys plug this all, you can plug all that into your calculator at once. Just save yourself some writing. So we'll get 14,437,500 times x to the power of 36 minus 3 times 6 is 18. So it'll be to the power of 18. Okay. So we didn't have to do a check because we know there's a 13 middle term. There has to be a middle term. Wonderful. Okay, let's do another example quickly. We'll probably go through this one a little quicker since we have some experience now. Okay. So x squared minus x 1 over x. So I have my n is equal to 8. A is equal to x squared. B is equal to negative 1 over x. We have x in both, so we're going to have to cancel some stuff out in our general term. Okay, and then also just want to note r will be between 0 and 8. Okay, so for all our answers, there's r is going to be 0 between 0 and 8, and there are 9 terms because it's 1 more than my n value. So t to the r plus 1 is equal to n, choose r, a to the power of n minus r, that's b to the power of r. Okay. So now I'll have my n is 8, choosing r. I have x squared to the power of n minus r. I have negative x over 1 to the power of r. Okay, so again, oh, sorry, I forgot to sub in what n is there. I know that n is 8, so I'll put 8 there. Okay, so now You can distribute, remember, it becomes multiplication. So we have to multiply the 2 by the 8 and by the negative r. Okay? And then that r gets applied to both of these. And instead of doing like putting the negative out there, it'll be easier just to put the negative up only to the 1. Okay? And you'll see why in just a minute. So I still have 8 choosing r is equal to x to the power of 16 minus 2r times. I have negative 1 to the power of r all over x to the power of r. And now because this is all multiplication, I can switch the positions of these two. Okay, so I have x choosing r all over, or sorry, times negative 1 to the power of r. Let's fix that bracket there. So I have x to the power of 16 minus 2r all over x to the power of r. Okay, so now I have all my x's together and all my r's and all my numbers together here. I can do one more thing. Because we have the same base here, I can subtract the exponents. Okay, so that leads me to my final simplified solution of t to the power of r plus 1 is 8 choosing r times negative 1 power of r. And I have x to the power of 16 minus 2r minus another r. So that simplifies to would be 16. 2r minus another r would give us 3r. And that is the general term. T to the power r plus 1 equals 8 choosing r times negative 1 to the power of r. So that's just going to flip a sign on it each term times x to the power of 16 minus 3r. Okay. So the general term will change for every binomial that we have. Okay. Every binomial has a different general term. Okay. But then once we find the general term for this specific binomial, so as an example 2, for now B, C, and D, we're just going to use this specific general term for those questions. Okay, so we're going to find the term containing x to the power 2 if it exists. So that means that we're going to have to check. So up here I had 16 minus 3r is my exponent on x. So I have 16 minus 3r, and I'm going to set that equal to 2. And I know that has to be a whole number between 0 and 8 because my n is equal to 8. So let's bring 16 over. I have negative 3r is equal to 2 minus 16. Negative 3r is equal to negative 14. Divide both sides by negative 3. If r is equal to 14 divided by 3, which is a fraction, right? And it has to be a whole number, can't be a fraction, so not a whole number, therefore does not exist. So in this binomial expansion, we won't have any term with an x squared on it. Okay. Next, the term containing x to the power 7, if it exists. So again, let's do a check. So I'm still using my same 16 minus 3r, but this time I'm going to set it equal to 7. Okay, so negative 3r equals negative or 7 minus negative 16. Negative 3r will then be equal to negative 9. If r is equal to negative 9 divided by negative 3, so r is equal to positive 3. Okay, which Positive 3 is an option because it's a positive whole number. That's between 0 and up to my n. That's 8. Okay, so I can sub this into my general term. Okay, so I have 8 to the power of r times -1 to the power of r x to the 16 minus 3r. So that was my general term. T is equal to 3 plus 1 is equal to 8. Choose 3. -1 to the power of 3. X to the power of 16 minus 3 times 3. Okay. So 3 plus 1 is 4, so I know that's my fourth term. 8 choose 3 should be 56. -1 to the power of 3 is going to remain -1 of x to the power of 16 minus 3 times 3 is 9. That's really here what you can do in the steps because we got space here. So 16 minus 9. So that will change my 56 to be -56 x, a little bit more, the power of 7. Okay, which is good because we were looking for this term. If we don't get x to the power of 7, something's probably wrong. So the term would be this fourth term, and it's -56 to the power with x to the power of 7. And I don't want that. I just want this. Okay. So the term containing x to the power of 11 if it exists. So let's do another check because it's asking if it exists. If I don't say if it exists, then you know that this does exist. That's a little helpful hint. So 16 minus 3r is equal to -11. Bring that 16 over again. I'll have -11 minus 16. -3r is equal to -27. R is equal to -27 all over -3. So R is equal to 9. So do I sub that in? No, remember, my n is 8. So R must be between 0 and 8. Okay. Therefore, there is no such term. Okay. Because R would be greater than n. Okay. The main reason why we can't have R bigger than n is because of our combination formulas. If I have 8 choose 9, how's that possible? If I have 8 people in a group and I need to choose 9 of them, I can't choose 9 people of 8 because I don't have enough people. Okay. Remember, n always has to be bigger than r. So if we have r greater than n, mathematically, yes, we do get a positive whole number for r, but it's not in the range that we have. Okay, so therefore, does not exist. Okay, so with these finding particular terms, you want to first, and that will always be the first question, is to find the general term. Well, I might ask how many terms there are, but you want to find the general term and fully simplify it just to make it easier on yourself. And then you can check to see if terms exist and what they are. Okay. So just one other thing. Whenever I say term, I'm asking for the whole term. For term, that would be the whole thing. If I was asking for coefficient, if I just asked for the coefficient, that would just be looking at the -56. Because I just want to see, well, I already know that's going to be x to the power 7 is here. I want to see what's the number in front. So that's the coefficient. So if I asked for just the coefficient, it would just be the number part. It won't have the x squared or x to the power 7 as well. Okay, so that's it for this lesson. So now we are done everything up to the first quiz. So the first quiz is only going to be on the first 3 lessons, so expected value, and probability distributions, and then the binomial theorem and Pascal's triangle. Okay, so please let me know if you have any questions about anything, and we will see you for our last two lessons of the class. Bye.